G'day Year 11s. Alright, we are doing 2E today, characteristics of distributions of numerical data, shape, location and spread, which is a fancy way of saying we're looking at graphs of numerical data and learning that there are three categories of discussion that we can have about those distributions, okay? If you describe to someone the shape of your distribution, its location and its spread, then you've pretty much given them all the information they need to have a general understanding of what that distribution, what that graph represents, okay? All right. Now, we're going to start with shape, okay? Now, for the purposes of learning about these three categories, on the horizontal axis, we just have score. Think of that as representing anything you like. It really doesn't matter. I'll choose something real simple like number of siblings, okay? So if I zoom in on this one, we could imagine that one person has one sibling. 4 people have 2 siblings. 10 people have 3 siblings. 4 people have 4 siblings. 1 person has 5 siblings. Or something like that. But you really don't need to imagine this stuff in context. You learn the theory and then you apply it to the context later. Okay, so back to the theory. All right, so here we go. Here we have a symmetrical distribution. Here we have a positively skewed distribution. And here we have a negatively skewed distribution. And I should also mention the vertical axis is frequency, as always. Now, if your graph has a symmetrical step-like function like this, which kind of looks like someone's sticking their naughty finger up at you, okay, that's a rude way to put it, but a very good way to remember it, then it is symmetrical, okay? We would describe the shape as being symmetrical. So if someone asked you in a SAC, what is the shape of this graph? You would say symmetrical. Or even if one of these bars was a little bit higher, let's say that bar there is a little bit higher than this bar here, we would still say that is roughly symmetrical or approximately symmetrical. These cases that I'm showing you today are all pretty perfect. But in the real world, you don't get perfection like that. So you would say approximately symmetrical. But this one here is exactly symmetrical. Another way that a distribution can be symmetrical is sort of the opposite. That is if the bars go down and then go up in the same way. Okay? That is also a symmetrical graph. But once again, if one of these was a little bit higher, maybe this one was a little bit higher as well, you know, we could still say that that's an approximately symmetrical graph. All right, positively skewed. Now here's where people get confused. If the frequency from left to right gets smaller as you go along, as the score gets bigger, this is the score, the frequency becomes smaller, and you can see that it's not perfect because this one was smaller than this one, but this is just an approximate case. Then we say that this is an example of a positively skewed distribution. Now the reason this confuses people is because when we do linear graphs and you have a line that's going downhill from left to right, we say that it has a negative gradient. But we're not talking about gradients. We are saying that this distribution is skewed, crooked, towards the positive side of the horizontal axis. So if it's going downhill on average, then we describe it as positively skewed, okay? So don't get that confused with your linear graphs. And the same thing happens with a negatively skewed distribution. If we have score versus frequency and the bars are increasing, okay, then this is called a negatively skewed distribution. But if we just had a straight line linear graph following a similar trajectory, that would be a positive gradient, but we're not talking about gradients, okay? All right. So that is shape. Symmetrical, positively skewed, negatively skewed. Actually, I always forget to do this. There is one more way that you can have a symmetrical graph. And that is if all of your columns are exactly the same height. Doesn't pop up very often, but it's worth mentioning, okay? All right, so that is shape. Moving on to location. Now, let me just read from here actually. Two distributions are said to differ in location if the values of the data in one distribution are generally larger than the values of the data in another distribution. But the two histograms that we're looking at have an identical shape. The only difference is that one is shifted along the horizontal axis relative to the other one, okay? So if we have a look at this here, if that were to move along to about here, okay, then we would get this graph here. See how this graph has its last bar ending at 11, where this graph has its last bar ending at about 16, okay? So these two histograms have the same shape, so the same steps, in other words, not using very mathematical terminology here, exactly the same steps. So each one of those columns, those bars, would have the same frequency value on the frequency axis, but the horizontal value, whether it be score or whatever the case might be, is different, okay? So it's just a translation from left to right, but the shape of the actual columns is exactly the same from one graph to another. So that is location. All right, now the final way that we can describe a distribution is through spread. Now, two distributions are said to differ in spread if the values of the data in one distribution tend to be more variable or spread out than the values of the data in the other. Now you can see that in this histogram, our values are clustered around about that range, okay? Whereas in this histogram, there is a much greater range, okay? Now, it might be the case sometimes that if you add up the value, so the corresponding frequency value of all of the columns here, now it might be the case that if we add up the frequency, which would require us to go across here to the frequency axis, if we added up the frequency of all of these columns, you might get exactly the same value as if you added up the frequency of all of these columns, even though one is more spread out than the other. So that would mean that in the group here of columns that are less spread out, if the total of the heights of all of those columns is equal to the total of the heights of all of these more spread out columns, that would have to imply that these columns here are shorter or not as tall, okay? But that won't always be the case. All right? So, in summary, if you are asked in a SAC to describe the shape, location, and spread of a distribution, if you're even asked to describe a distribution, what they are usually getting at is that you will immediately know that there are three main categories that you should be thinking about: shape, location, and spread. So you would use a word to describe the shape, you would use a word to describe the location, and you would use a word to describe the spread. Okay? Hopefully that's enough to get you started on the exercise, guys. Nice and short one today, and I'll see you next time.